Hello and welcome to the Levers and Pulleys screencast. I'm Jose Rosa, science specialist at the Mason Pilot Elementary School in Roxbury. Now, if you've seen my other screencast, you should be used to my action figure collection. Now, take a few seconds and look at the action figures behind me. There will be a quiz at the end of this screencast. Anyway, let's begin our screencast. During this screencast, we will be going over Investigation 3, Pulleys. Now, I really, really enjoy teaching about pulleys. I enjoy it a lot more than teaching about levers. There's just something about pulleys that is fun to do with the students. Now, this investigation has 3 parts. Part 1 is 1 pulley systems. Part 2 is 2 pulley systems. And part 3 is the pulley game. Now, the pulley game is an awesome activity where students get to practice while playing a game, and they practice building the 4 pulley systems from this investigation. And although students collect some data during this investigation, the bulk of the data will be collected during investigation 4. Now, let's go over the parts you will need for investigations 3 and 4 of this unit. You will need meter sticks, binder clips, spring scales with paper clips, not the rubber bands that you see on the picture, 2 loads with or without rubber bands, works either way, 2 single pulleys, and 2 ropes that are 75 centimeters long, and heavy books to put weight on your system. Now, if your ropes are not prepared, you will need to prepare them by cutting 18 pieces of rope, 18 centimeters long, and then creating loops on both ends and taping them securely. This is all outlined on page 9 of your folio. Again, I find it useful to store each group's materials in a Ziploc bag. Now, you will use the same duplication master for parts 1 and 2. Part 1 focuses on a single pulley system. Students measure effort on the 2 single pulley systems and complete a data table. Important note, students should add 0.5 newtons whenever they pull down on the pulley system. They should not add 0.5 newtons when they pull up. Remember why? Let me give you some think time. Okay, when pulling down, gravity is also helping pulling on the scale, which weighs 0.5 newtons. So you have to add the weight of the scale to the overall reading of your of your pulley. And before having students build both pulley systems, demonstrate how to put the parts together. A heavy book comes in very handy when securing the system to the table. Advantage is also reintroduced during part 1. However, the concept of advantage is broadened by introducing mechanical advantage and directional advantage. Mechanical advantage is when the effort is less than the weight of the load, and directional advantage is when the pulley system changes the direction of the effort. For example, pulling down to move a load up. Before going over part 2, let's look at the data from part 1. Do you notice the difference between the effort of a single fixed pulley and a single movable pulley? Why do you think that is? We'll explore this later. Okay, so while part 1 explores single pulley systems, or that is pulleys systems made up of 1 pulley only, part 2 explores 2 pulley systems. Students first try to figure out how to assemble 2 pulley systems in teams. If they're struggling after several minutes, give them some guidance. After each group successfully builds a 2 pulley system, show them how to draw diagrams of the 4 different pulley systems. See page 19 of the teacher guide. Students will need their diagrams for part 3 of this investigation. Part 2 also introduces the term simple machine, which is described as devices that make work easier and provide some advantage. Lastly, part 3 of the investigation, the pulley game, mainly focuses on having students practice building the 4 different pulley systems they had already explored. Practicing will make it easier for when they get to investigation 4. And again, they should be using the pulley diagrams that they created to guide them during the pulley game. You can also post these posters up on the wall, and students can refer to them during the pulley game activity. Now, before wrapping up this screencast, I want to discuss complex machines. Now, a simple machine is a device that makes it easier for us to do work. For example, opening a bottle, lifting a heavy object, or peeling a potato. However, most simple machines or tools that we use today are actually complex machines. Some of the tools the students explored during Investigation 2, as a matter of fact, are actually complex machines. Let me explain why. Complex machines are machines that are made up of more than one simple machine, while simple machines are made up of only one simple machine. Let's consider the scissors. We know that the lever is part of the scissors, but so is the wedge. And some, like this one, even have screws. So that makes it a complex machine. Okay, that's it for this screencast. But before signing off, do you remember my quiz? Were you paying attention to my action figures? During this screencast, I changed one of the action figures. The question is, which one? If you said the Hulk, you are right. I switched the Hulk for another Hulk. So I made it a little bit harder that time. So hopefully you guys got the answer correctly. And I know I'm a dork, but it's my thing. This is the way I am. But anyway, until next time, as a famous Terminator once said, I'll be back. Goodbye, folks.